Hello, this is our Excusa. Welcome in the Artificial Intelligence and Product Strategy podcast. Today, I would like to continue the topic about how Metaverse and AI can go together. Especially today, I would like to introduce you to a few techniques how artificial intelligence can empower Metaverse, and putting in other words, why Metaverse cannot exist without artificial intelligence support, if I may. It's a support, it's more like integral part. But anyway, let's talk about how Metaverse can actually benefit from artificial intelligence. And I have today 6 different areas in which artificial intelligence is necessary to boost the experience that we want to have in Metaverse. First is everything what is connected to language processing. As you're probably familiar with, different models that artificial intelligence can bring on the table when it comes to processing language. Here we are talking about text-to-speech, speech-to-text. We are talking about semantic labeling, word prediction, or language modeling. Anyway, whatever technique we pick up, it's worthy to consider such a scenario that currently Meta is working on, and an interesting use case where artificial intelligence is a necessary part of it. Imagine you meet somebody in a virtual world and that person comes from Argentina and speak the local dialect language, and you are here visiting from United States of America speaking Southern States dialect English native language, and you both meet in the Metaverse. If you meet in the real world, the physical world, you both need either analyzing the language through translator and give you a translation on the screen using, for instance, Google Translate, or you can use your personal skills. You might understand a little bit of that dialect from Argentina, and that person can understand a little bit of the English, and you can try to use that. Then you can always use piece of paper and pencil to draw what you want to say. Doesn't matter which technique we pick up in the real world, there's always a delay. The delay is connected to the middle tier that is responsible for translation. In a Metaverse, we don't have a middle tier, which actually influences the strategy of how language processing is being used in the Metaverse. In Metaverse, there is no delay, so that person speaking in a dialect from Argentina needs to be able to understand your English language, you coming from United States, and that's where are the models responsible for that. Those models come from language processing models that are strictly coming from artificial intelligence. Whatever we use, if it's a machine learning or deep learning or neural networks, or we use supervised and unsupervised model algorithms, it doesn't really matter. The most efficient algorithm will win. But in Metaverse, this is one of the area which is absolutely critical for Metaverse to exist and give us a relevant experience. The second area is machine vision. Machine vision, it's everything what can be recognized through pictures and videos, and algorithms can process that. For instance, we have a classic case, whatever it's a cat on a dog on a picture, but we have more diversified cases like understanding our faces, or understanding a car plates, or understanding a shape of the watch, what kind of beverage is in the cup, or what is actually on the table. It's in a book, smartphone, coffee mug, or an apple. All that can be understood by algorithms through processing images or videos. And that's the second family of techniques that we can mention here, like object detection and segmentation, image restoration and enhancement, and pose estimation and action recognition. I would like to elaborate on both of them. I found very exciting. One is an image enhancement. In a Metaverse world, we want everything to be perfect, high resolution. That's why we need like 5G or even 6G internet, huge transfer with a latency close to zero. We want everything to be enhanced. But if you think about software like Topaz or Adobe, when you can upload a picture of your last bird you photograph in your forest near your house, Whenever you upload that picture can be enhanced by the software. The same happens when you take a picture by your smartphone, for instance, Samsung or iPhone, and then you can see a difference between the picture you took and the picture you see actually on your screen. That's our enhancement techniques. Enhancement can be easily delivered by AI, for instance, by reducing a noise, sharpen the colors automatically, by analyzing pictures that are on an image and then trying to squeeze as much quality as possible from them, or simply restoring part of the picture when it's missing. For instance, you take a picture of the nice landscape, but you cover a camera partially with your finger. It's very easy to remove your finger from that picture and fill up this empty space with something that matches the landscape. That's the techniques that are widely used in Metaverse to give us a seamless experience when it comes to experiencing the high quality content. When it comes to pose estimation and action recognition, today when you put your MetaQuest on your head or any other device this type, then you can need to grab two joysticks or two devices that you keep in your hands, and that's how you navigate the virtual world. In the future, we will be just moving our body around, and the virtual world will simultaneously reflect that. That's what is a poses estimation and poses recognition. Estimation here means that we can predict, algorithms can predict where you go by analyzing your style. Imagine yourself playing NFL 2022 on your MetaQuest, and after a while, algorithms can learn your moves. Basically, we all have moves. For instance, if you are taking a daily jog and you analyze your jog through your Apple Watch, you can see what's the size of your single step. Mine, for example, is 0.9 meters, which is every time the same size of my step. If you use that analogy for your body movement, we can estimate a lot of different measures. So in the future, by moving around in Metaverse can predict what is your next move, how you catch that ball, how you grab the tennis racket, or how you actually make that push-up. So that's what is the technique in terms of machine vision. What is a machine vision? Because all of that is delivered through images, videos that are actually grabbed by sensors, cameras, or voice or microphones. The third part is blockchain. Blockchain basically consists of three techniques: data collection and sharing, data storage and management, and data security and privacy. Blockchain is pretty well known around for those who are interested in blockchain. Also, cryptocurrencies are kind of a flagship of blockchain leverage. But I want to tell you about something else: data collection and sharing. This is a pretty good example that artificial intelligence is very useful in it. Imagine you buy the digital land or any digital good, and you need to sign a contract to be an owner of that. That contract is flying to you as a document over your virtual reality glasses. So you can see a digital document, something similar to, for instance, a Pages document on your Mac or Word document or your PC, but it's digital. Normally, you probably put it on the software that helps you to signature that and send it back. But that document can be recognized on the fly. So basically, the specific parts of this document can be highlighted for you, like the risky clauses or risky element that you need to pay special attention to. That is a data recognition, and then that data can be collected and segmented and sharing through different parties. So this is the case when artificial intelligence techniques like text recognition, object recognition on the papers, text extraction, handwriting recognition can be leveraged to give you those highlights and then share that data across different parties. For example, with your wife that is also an co-owner of this, or your partner that is co-owner of that, or your lawyer or your mom, dad, whatever you want to bring to that document. And everything what is shared is absolutely secure because it's the blockchain. And this kind of scenario is a well-known scenarios in the NFT world when you actually can experience similar processes. The fourth technique is networking. ultra reliable and low latency communication, multi-access edge computing, and intelligent spectrum utilization. Let me here talk to you about low latency communication and management. Depends on which room in your virtual world is more trafficked with more people. That's how automatically the internet connection and internet latency can be managed. So for instance, we have 3 different worlds, and in one world there is more people partying, for instance, and having that fun. So artificial intelligence can enhance that one particular room and keep the 2 other rooms that are left and empty with the lower quality of the graphical experience. In that meaning, that 2 rooms that are now lower quality, they require less internet connection and less and the kind of not that perfect latency comparing to that room that is full of people. That's intelligent management is known from network management, artificial intelligence power network traffic management that comes from actually routers and switchers. Before, the new routers and switchers that were responsible for managing the traffic were managed by software that is installed of them and configuration that was done by administrators. And now the artificial intelligence becomes an administrator and can automatically administrate those networks. And those techniques are already well known. There are a few well-known startups that are delivering that services. So this is the 4th area. The 5th area are digital twins. In digital twins, we have 3 subcategories or more sub-containers, I would say: data-driven modeling, physical digital view integration, and analysis, monitoring, prediction, and simulation. Again, I want to mention BMW factories built in the digital world. For those of you that this topic is new, I want to mention this: that BMW built digital factories that are a copy of physical factories. Why they did it? Mostly to simulate for simulation purposes. BMW want to make sure what happened when the particular robot stopped working, or what happened when the particular supply chain was broken and the parts of the BMW cars are not delivering on time, or what happened where is the earthquake in the area, or the specific legislature is changed, like CO2 requirement, how that influenced the factory and manufacturing process. Those digital factories are built in a digital world, in Metaverse, just to simulate different action and different elements that can actually influence the manufacturing process. To have that factory built one-to-one as a very reliable copy, you need to have at least data-driven modeling. Why data-driven model is important? Imagine this, that is actually AI-powered action. You take a picture of an object, let's see it's a shoe, and then by analyzing that shoe shape, you want to design a new shoe. So artificial intelligence can understand what is on the picture, and then based on the characteristic points, design the new shoe based on that shape. The same analogy we can use for building digital twins and factories. You take a picture of the robot, and that robot is automatically designed in a virtual world. In the healthcare industry, we have a better experience. We have another example that you can scan our body organs, for instance, a heart or a stomach, and then build a digital copy, digital twin of that. That's what is actually driven by data, by artificial intelligence, where different algorithms are used, like CNN or supervised different algorithms that actually swallow thousands of pictures and build that stomach, that heart, or that robot in a virtual world. So that's basically what is data-driven modeling that is part of the digital twin. And the last one is neural interface. Brain-computer interface, invasive and non-invasive signals, and mental state analysis. One of the example is companies in a biotechnical world or in a healthcare are trying to analyze what happened with the brain in a specific situations and then program that word for us. One of the great case studies we know are use cases leveraged by Army. When you analyze what happened with the brain of soldiers that were serving in a specific conflict or war, and then after analyzing their brain, you can design the world that will help them to handle that stress disorder that happened after the conflict's participation. So for instance, you have a group of soldiers that were involved in a specific action. That specific action, the conflict, the war, causes influence their brain, and that brain can be analyzed through signals, and then depends on what kind of challenges those servants are facing. The digital worlds in Metaverse with different missions can be designed to help them to get out of this post-war stress disorder. That kind of elements are also leveraging artificial intelligence. How a signal can be turned to images, and the images can analyze the situation, how strong is the disorder. There was a lot of experiments before Metaverse that helped soldiers to handle that post-war or disorder and stress situations. So I hope those 6 areas will give you a full scope of picture, a comprehensive picture how artificial intelligence actually contributes to Metaverse and why Metaverse can not exist, or maybe putting in other words, why Metaverse needs artificial intelligence to deliver experience, to deliver different flows that Metaverse actually offers to us users and those who want to either entertain in the Metaverse or just do business in Metaverse. Thank you so much, and I see you in the next episode.